Hello everyone, welcome to MRU E-Learning powered by Multivariate University. I am Priyanka Chomwal, Assistant Professor in Department of Data Science, Multivariate University, and today I will be delivering a class on Exploratory Data Analysis. So, Exploratory Data Analysis, or we call it as EDA, is an important process in data science as this is the step where raw data turns into the real insight. Before applying any machine learning model or before doing any prediction, we must understand our data properly. So let us begin with today's session. Look at the agenda for the today's session. So in today's session, I will be covering the topic like what is EDA, why EDA is important, what are the different approaches to perform the EDA, and what are the different steps by which we can perform the EDA by taking a simple dataset as an example. I am sure at the end of this session, you will be able to understand how and why we are performing the EDA on a dataset. So let us begin with the first topic, that is what is exploratory data analysis. So exploratory data analysis is a process of exploring and understanding a data without applying any machine learning algorithm or without doing any predictions. In a simple word, I can say that getting to know your data before doing any fancy modeling or the prediction. So when we perform the EDA will try to answer few questions like what data do we have? How many variables are present in our data set? Do these variables are related with each other? What type of data the variable contains? Also, we need to find out, do we have a clean data set? Like, do we have any missing value, null values or error present in my data set? Are there any outliers present in my data set? EDA will answer all these questions with the help of statistical summary, which is nothing but computation of mean, median, mode, variance, standard deviation, and by using the visualization tools like bar chart, pie graph, scatter plot, and so on. So, EDA will help us to understand the structure of the data. Now, what comes in the structure of the data? Structure of the data will tell you what are the variables available in the data set, what is the data type of those variables. In a simple term, I can say that the column names present in the data set are nothing but my variable. So in the structure, we will find out what is the data type, are there any missing values present in my data or not. After understanding the structure, we will move on to identifying the patterns. Now, identifying the patterns. In the EDA, we can use the different visualization tools like scatter plot, bar graph to identify the patterns. Let me take one example to make you understand this topic properly. Let us take one student dataset. The student dataset contains student ID, student name, study hours, exam score and the attendance. So if I want to know whether the study hours are related with the exam score of a particular student, I might use some sort of analysis and I might use some sort of graph like scatter plot to understand the relationship between study hours and the exam score. Then EDA also helps us to find out the outliers. Now, what are the outliers? Outliers are nothing but the extreme values present in my dataset. So, in case of a student dataset, I can find out is there a very low value or a very high value present in my marks column. Why I am going to need these values? So that I can identify are there any low performance or high performance present in my class. Afterwards, we can check for the assumptions. Now, what sort of assumptions we are going to check? In this, we are going to find out are my values are in a proper range. For example, in the marks column, the values must be ranging from 0 to 100. Also, we can also check, do I have any negative values in the marks column? And in the end, we are going to summarize our key point. So, this will give us the clear idea about what actually EDA does. I hope you got a basic understanding of the EDA. Now I hope you got some idea about what is an EDA. EDA is nothing but exploring your data by asking the question, understanding the pattern, identifying the outliers, and at the end summarizing your key points. Now here comes the $1,000,000 question. Why we are putting so much effort on the EDA rather jumping straight onto building the models? EDA is a critical process in the real projects. EDA helps us to enhance the understanding of the variable by computing the summary statistic. As I have told you earlier, variables in a simple language, I can call my column name as the variable in case of the data set. So we will get the understanding of the variable, like what are the data types, what is the minimum value in my data, what is the maximum value, what is the average score of the student with the help of the summary statistic. Then EDA also helps us prevents garbage in and garbage out. If you are going to give the bad data to the machine learning model, you are going to get the bad output. Then how it is going to avoid that? It is going to avoid this garbage, sending the garbage data by cleaning your data. In the cleaning data, we are going to remove the duplicate values. We are checked for any missing values, null values, and according to the requirement, we can either delete the columns or the rows. Also, we can perform the imputation. We can replace the missing values. Depending upon the required action, we are going to clean our data set. So, if we give the clean and error-free data to our machine learning model, we can get the accurate and the trustworthy outputs. Next is EDA helps us. It reduces the time and cost of modeling by understanding the distribution upfront. Now imagine you have spent 50 lakhs rupees in preparing one machine learning model, and after deploying that model you are getting all terrible prediction. So all your time, money and efforts are wasted here. So what we are doing in the EDA, we are analyzing the distribution of data. How we are going to find the distribution of data? By using the plots like histogram. Histogram can be used to understand the distribution of the data. Also, we can use the statistical summary like variance, standard deviation to understand the distribution. Once we get the idea about the distribution of data, it will be helpful for us to select the proper model for our data. Also, we need to understand, do we need to perform any kind of transformation for our data? So, all this understanding we will get to know after getting the idea about the distribution of data in our data set. Last but not the least, EDA supports better storytelling and decision through the visualization. Rather than getting understanding by looking at the data, analyzing the data, if we have the graphs and plots in front of us, we'll get the understanding of the patterns easily. That's the reason EDA helps us better storytelling with the help of the different graphs and plots. I hope you got an idea why we are spending so much effort, time and money on performing the EDA. Now, till here we got a basic understanding why we are doing the EDA and what is an EDA. Now, if I want to perform the EDA, what are the different approaches available for it? So, depending upon the different purpose. For example, suppose I want to analyze a single variable in my data set, or I want to check the relationship between two or multiple variables in my data set, or I want to see how the multiple variables are interacting with each other. So depending upon my purpose, we have the three different approaches in the EDA. The first one is the univariate analysis. The univariate analysis deals with a single variable at a time. We are going to analyze one variable from our data set at a time. It does not study the relationship between the two variables. Instead, it focuses on describing the single variable, how it behaves across all the observation. The techniques and tools used in the univariate analysis are histogram, box plot, summary statistic. If I want to know the distribution of data, I will go for the histogram. If we want to find out what are the outliers present in my data set, we will use the box plot. Also, we will get the understanding of our data with the help of summary statistic, in which we will calculate what is the average value, what is the minimum value, what is the mean of the data, what is the middle data available in the data set. So this is about the univariate analysis. Now, if I want to analyze the relationship between two variables, suppose, let me take one example. We want to understand what is the effect of study hours on the student's exam score. Means here, our two variables we are taking for the analysis. One is the study hour, another variable is the student score. If I want to analyze these two variables and check the relationship between those two variables, we will go for the bivariate analysis. So, EDA uses the different techniques like scatter plot. Scatter plot is useful for showing the relationship between two continuous variables, or we can use the correlation analysis, which will tell us whether our variables are strongly correlated, weakly correlated, or there is no relation at all between these two variables. So in the bivariate analysis, we are going to analyze two variables to understand how they are related across all the observation. Then if we want to know how the multiple variables are interacting with each other in our data set, we will go with the multivariate analysis. It is nothing but assessing 3 or more variables at the same time to see how they work together. EDA uses the different techniques like pair plot, correlation matrix, and also the PCA, which stands for Principal Component Analysis, to perform the multivariate analysis in the data. If we talk about the example, suppose I want to know how the student's attendance, student's study hours, student's internal marks are affecting his final score. Then in such case, I will apply the multivariate analysis and we can use any technique which is mentioned. Now, let us see the roadmap that guides you through the entire EDA process. So here is a 7-step EDA process. In the first step, we need to first define a problem. For example, I want to know what is the effect of study hours on the exam score. So I should have a clear problem definition to perform the EDA process. Once the problem is defined, we can move on to the second step, that is nothing but the collection and the importing of our data. We can use the different tools and techniques for collecting and importing our data. Like in the Python language, we are going to import the pandas package, also the numpy package. Pandas is useful for manipulating and creating the data frame. Also, the numpy package is used for performing the numerical calculation. For loading the dataset, it can be a CSV file, it can be a JSON file, it can be a XML file. We have the different functions available in the pandas package. After we load the dataset and we load it into a data frame, we will inspect the structure. We can use the different functions like .info, .shape, .describe to get the basic understanding of the dataset. Now, in inspecting the structure, we will come to know how many variables are there, what are the names of those variables, what are the data types of those variables in my dataset. After we come to know about the structure, we will move on to the most important step in our EDA process, that is cleaning the data. Now, cleaning the data is divided into the two parts. First, we need to identify, are there any missing values present, are there any duplicate values present, or there are any null values or error present in my dataset. For that, we will use the different functions in the Python to identify the missing value, null values, and duplicate values. Once we identify the missing value or the null values, we have to take the required action. Suppose if in my data set, out of 80 entries are with missing values, no values are there. So instead of replacing those missing values, I can simply delete the column, which won't affect my analysis. But suppose if in my column, that column is very important for my analysis, I will go for the replacement. Now, replacement is also called as imputation. It can be done with the different techniques. Like if you have the normal distribution of the data, we will replace the value with the mean. If we have the skewed data, we will replace the value with the median. If we have the categorical variable, we can use the mode. We can also use the forward fill or the backward fill for the imputation. So after your data is clean without any null values or any errors, now we can move on to performing the univariate analysis, bivariate analysis, and in the end we will summarize our insights. In univariate analysis, as we have already discussed, we'll talk about the single variable and what insights we can get it from that single variable. In bivariate analysis, we are going to check the relationship between multiple variables. Let me explain you this process with the help of the example. So here is our problem statement. An engineering college wants to understand what factor influence students' exam performance. The academic team has collected the data for one semester with the following columns. I have already explained columns are nothing but my variable. So in our data set, as you can see, we have the column like student ID, name, branch, study hours, attendance, internal marks and the exam score. And our problem definition is we need to find out what are the factors which affects our student score. Okay. So after our data is collected, we are going to import the packages like pandas, seaborn and matplotlib. Pandas is useful for data frame creation and the data manipulation. Seaborn and matplotlib are used for the data visualization. Here we are using the function read_CSV to load our student CSV file into a data frame. Once my data is available in a proper structured format, we can go for the basic structure inspection. We will use the functions like df.shape. It will give us how many number of rows and columns available in our data set. We can use .head. It will give us the first 5 rows from our data set. We will use the function like df.info. It will give the complete information about your data set, like what is the column name, what are the data types of the column, how many non-null values are present in my column. And in the end, we will go for the df.describe. It will give the statistical summary of the data set. Once we got the basic information, basic idea about the data set, now we will move on to the cleaning the data. I have already explained in the cleaning, 2 parts are involved. First, we need to detect where is the missing value. For that, we are going to use the function isNull. IsNull function will tell you about the missing value. Then, after that, once we find out the missing value, we will go for the handling those missing value. Either we can drop the row with the missing value, or we can drop the column with the missing value, or we can perform the imputation. So in our example, we have used the function isNull.sum, which will give you column-wise total number of missing value. Also, we are checking for the duplicate values, how many duplicate records are present. Once we'll get the idea about the missing value, we will try to replace those missing value. Here, as you can see in the data set, in the attendance column, we have the 2 missing values. So these 2 missing values we are replacing with the median value. Right? So let's move on to the next step. After your data is cleaned, error-free, now we can move on to the analysis part. Here we are performing first univariate analysis on the variable exam score. And we have plotted one histogram and one box plot. Now after plotting the histogram is used to understand the distribution of the data. So from our data set, after plotting the histogram, we are getting the key insight like exam scores are roughly ranging from 45 to 92. Most of the students belongs to in this range, 45 to 92. Also, majority of the students are average to good range. The median exam score is around low to mid 70s. From the box plot, we can understand that the median is near to the 70. A few score near to 45, which comes under the low performers, and also the high score like 90 plus, which comes under the high performance. So from the univariate analysis, we will come to know what is the range of the student marks. Also, we'll find out who are the low performers and the high performers from our class. Then, we have moved on to the bivariate analysis. In the bivariate analysis, we have taken 2 variables, study hours and the exam scores. And we have plot a scatter plot. Now, scatter plot is used to give the relationship between 2 continuous variables. From this plot, we will get the key insight like it is clearly an upward trend, indicating that students who study more number of hours will achieve the higher exam score. Also here we have calculated the correlation matrix. The correlation value between study hours and the exam score is strong and positive, indicating strong positive linear correlation between these two variables. I hope you have got some idea about how to perform an EDA. Now, let me conclude my session by telling you the best practices while performing the EDA. We must be iterative, like we should always ask questions to our data. If we are not getting the proper answer, we should refine it and we should ask the new question. We should always visualize everything. By seeing at the numbers, you might not get understanding of the patterns, but when you see the graphs and plot, you will have the clear understanding of the patterns. Then we should always stay curious. Don't accept the first insight. Always dig deeper into the data. Document your findings. Write down what you have learned and why this is required. Also involve the domain expert. Someone who knows the subject can point out what is odd, what is wrong in your predictions. Also, we should be careful about what things we should not do. We should not skip the EDA. That may cost you so much efforts, time and the money. We should not ignore the outliers. We should always identify the outliers and also handle them. Confuse correlation with the causation. High correlation doesn't mean one causes the other. This is very important point to remember. Forget to document your findings. You won't remember why you did something. So always make sure you are documenting whatever the insights you are getting. Now, always be thorough, curious and document everything. I hope you got a understanding of the EDA topic thoroughly. Thank you so much.